In our development of consumer theory, we spent a bit of time thinking about the conditions under which we don't have to worry about things like corner solutions. We can do the same here for producer theory. And just as in consumer theory, convexity plays an important role. Consider first the usual shape for our production frontier. This creates a non-convex producer choice set because we can certainly pick points on the production frontier such that the line that connects those points lies outside the producer choice set. The existence of this non-convexity in producer choice sets makes it possible that there might be prices and wages such that there is a tangency between an isoprofit and the production frontier with a negative intercept for the isoprofit. In other words, it's possible that we have an isoprofit that's tangent to the production frontier with negative profit for all the production plans along that isoprofit line. When we solve our usual profit maximization problem, however, that maximization problem will give us production plan A as a solution to the problem, telling us that we ought to produce XA in output using LA as inputs. The true profit maximizing production plan is, of course, the production plan B, where we hire no labor and produce no output. This lies on an isoprofit line that has zero profit associated with it, which is higher than the negative profit at the production plan A, which is the plan that's suggested by the calculus solution to our maximization problem. Because there's no tangency between the isoprofit line and the production frontier at the plan B, the calculus method for solving the optimization problem does not give us B as a solution. Instead, it gives us incorrectly the solution A. If the wage and the price are such that the slopes of the isoprofit lines are relatively steep, we therefore cannot rely on the calculus solution to give us the correct solution. Instead, what we need to do is to check whether the solution that we arrive at in fact gives us positive or at least zero profit. If that isn't the case, if the production plan would result in negative profit, then we know that the calculus has not returned the correct solution to us, and that instead we must be optimally at a corner solution. If the production choice set is convex, as it is in panel B, it'll turn out that we won't have to worry about this. Whenever there's a tangency between an isoprofit and such a production frontier, it'll be the case that that tangency actually results in a production plan that gives positive profit. In other words, the isoprofit that's tangent at that point will in fact have a positive intercept. Thus, since the calculus solution arrives at tangencies such as these, we'll be okay to simply accept those solutions and won't have to worry about checking whether profit is in fact positive or negative. Thus, when the production frontier has a concave shape and therefore creates a convex producer choice set, we can simply use our usual calculus methods to arrive at the optimal production plan. If, on the other hand, we know that the production function creates a non-convexity in producer choice sets, we need to be careful about interpreting the solution that our calculus methods provide us. In particular, all we have to do is check whether the production plan that is offered as a solution in fact results in positive profit. If it does, and if there is no other solution that results in even greater profit, then we in fact have a true profit maximizing production plan. If the production plan that's suggested by the calculus method results in negative profit, we know that that's not a true profit maximizing production plan.